Okay, as far as the graphs in number 3 are concerned, we have one linear function to draw along with its inverse, and then one radical function to draw along with its inverse. The inverse of a linear function is going to be another linear function. The inverse of a radical function will be a quadratic function, but only one arm of the parabola. So we have to figure out how to indicate that with respect to the equation, okay? So with the linear function, we have to draw the graph of both f and f inverse. So let's draw f first of all. We have a y-intercept at -2 and a slope of -1/4. So let's see, we go down 1/4. We're here. Can even go back or keep going a little bit. It's going to be down there. Could even go backwards. 1, 2, 3, 4. It'll be there. And then the x-intercept is going to be all the way out here at -8. And just to be kind of careful, we can even get a ruler and line this up correctly. Okay, there's the graph of f. Now, to graph f inverse, we should just flip-flop all the x and y pairs. So 0, -2 becomes -2, 0. That goes there. Let's see, 4, -3, it looks like, becomes -3, 4. So -3, 4 is right there. And that's enough. All you need are 2 points to draw the graph of a line. So let's consider that sufficient. Oh, let's graph the y-intercept. The x-intercept here was -8. The y-intercept here is going to be -8, just to be a little bit more careful. Connect those dots. Here we go. That's f inverse. Label that somewhere up there. Okay. So now we've graphed the function f and f inverse, and you can kind of see, based on that y equals x line that my pencil's representing, they are symmetrical about that line. So we've done a pretty good job of that. Now I've got to write the equation of the inverse. Now that I have the graph, the equation's kind of nice. Think about what you know about linear functions. The y-intercept here is -8. If you didn't have that drawn already, you could kind of figure it out. Okay, but the y-intercept is -8, and the slope between the intercepts, you can just count to get the slope. From here to here, we've gone down 8 and over 2, so that's like a slope of -4. So we have -4x minus 8 as the equation of the inverse. Okay, so that's the first one. Second one, f of x equals negative the square root of x minus 4 and then plus 1. This is the parent radical function reflected over the x-axis, so it's going to open down, and then shifted 4 to the right and up 1. Okay, so let's start with the endpoint, which is going to be at +4, +1 right there, and go from there. Just in my head, I'm going to choose, instead of handling the parent function and then doing all the shifting, I'm going to just consider values for x that would make the y value a whole number, like a value of 5. So 5 minus 4 is 1, root 1 is 1. -1 plus 1 is 0. So 5, 0 will be a point. The next point I would use would be 8. 8 would give us a y value of -1 if we plugged it in, okay? So that's the way that the radical function is going to look, just like this. That's half parabola. It's half of a sideways parabola. Again, it opens down because the negative in front, but you would be able to see that just by plugging in the numbers and graphing the points. To graph the inverse, I would just flip-flop some x and y pairs. 4, 1 becomes 1, 4. 5, 0 becomes 0, 5. You see what it's going to look like now, probably something like this. What else? 8, -1 is now -1, 8. And the graph looks like this. Now, we've got to write the equation of f inverse, and we can do that by the graph. This is a quadratic function, right? The inverse of a radical is a quadratic. If you know that, make your life a little bit easier. We've got the vertex is at 1, 4, and it does open up. So we've got x minus 1 squared plus 4, right? The vertex is at 1, 4. But we're only considering x values less than 1, right? When you're drawing the inverse of a radical function, you got to make sure you restrict the domain because you only need half of the parabola, not the full thing, okay? And again, the y equals x line, we have reflectional symmetry.